Now we've just seen how we can use algebra to solve absolute value inequations, and we had those three rules that we can use, whether they're an equation or one of the two types of inequations. Now, this method I'm going to show you is a completely different method. It uses a number line to do the exact same thing. Now, I'm not a huge fan of this method, I'll admit, and the reason is I think that there's a couple of ways that you can get confused and make a mistake quite easily with this method. But I want to show you the method so that you can compare it to the other one. For you, it might just click and you might love it. And perhaps you won't make those same sort of mistakes that I find I make if I use this method. Now, to understand it, we need to think of a few things first. Distances are always positive. You can't be a negative distance away from something. We also need to know that when we're subtracting one number from another, we're finding the difference between those two numbers. So if I say what is 6 minus 2 and you say it's 4, then we know that 6 and 2 are 4 units away from each other on the number line. So we're basically going to use this concept to force our inequalities always into this form of x minus something or something minus x, okay, not plus. If we've got plus, what we need to remember is that if you've got negative minus something, that's the same as plus. So if you have a question that looks like this, you're going to rewrite it and think of it like this so that we always have the minus there. That's one of the areas that I think you can make a mistake, forgetting that part, which is why I'm explaining it first, because it's so important. We need to be subtracting the two numbers and then taking the absolute value. Because when we do that, x minus b in absolute value brackets means how far away x is from b. Okay? Now, what would happen if b or x was a bigger or smaller number than each other? Well, let's have a think. If we did 4 minus 6, for example, or we did 6 minus 4, this one gives us 2, and the absolute value of 2 is 2. But this one gives us negative 2, and the absolute value of negative 2 is also 2. So you can see that it doesn't make any difference which one comes first. What we're saying here is how far away is 4 from 6. So once you get your head around that, you can see that you must have a subtraction, and then it doesn't matter which order these two come in. Okay, so that's our concept. All right, what's the rule to use? Well, we say if something minus something, let's say x minus b, is in absolute value brackets and it equals a, then a must be the distance that they're apart, just as we just saw that 2 is the distance between 4 and 6. So what we can say then is x is a units away from b. So if that sits easily for you, you're well on the way to using this method. Some people think, hold on, I've got to think that through and it takes them a little while. So let's do an example. If x minus 5, absolute value, equals 7, what that means is that x is 7 units away from 5. So the way you'd solve that, draw yourself a quick number line, put your 5 down in the middle, and say x must be 7 units away. So it's either 7 units bigger, and I can easily do 5 plus 7 to get 12, or it might be 7 units smaller, in which case it's going to be minus 2. So then I get my two answers, x is minus 2 or 12. Now when we use the same concept with inequations, we say that if the absolute value of x minus b is smaller than a, then x must be less than a units from b. Because remember, we're looking at the distance here between a and b. We're making it positive so that we don't mind which number is bigger. And if we're saying that distance is smaller than a, then the distance between x and b is less than a. So how it works in practice, if x minus 4, absolute value of, is less than 1, what that means is that x is less than 1 unit away from 4. So your point of interest is your 4, and you're less than 1 unit from it. So go up 1 and go down 1, and you'll find that x must be then between the 3 and the 5. So you'd write your solution like this. Or if you're using your new notation, you could use round brackets and write it like that. Now, when you've got a situation where the absolute value of x minus b is greater than a, what you're saying then is that x is more than a units from b, because the distance between x and b is more than that. So in our example here, we're saying that if the absolute value of x minus 9 is greater than or equal to 3, then x is more than 3 units from 9. So on your number line, you draw your 9 and think about what's 3 units away in either direction. We've got 12 and we've got 6. X is further away than that, so it must be up here or down there. Notice how one of our types of questions gives us an in-between and the other one gives us an answer that's 2 tails. So here you'd say x is less than or equal to 6 or greater than or equal to 12. Now that seems quite straightforward. The time that you're likely to make a mistake or when it's likely to get tricky is when you get a question that's just a little bit harder. And what you've got to remember is we've got to force it into that form, x minus something is less than something. Now at the moment we've got this plus here, and this is where you could make a mistake if you're not remembering to force it into this form. So how do we do this? Well, let's start by saying we've got 3x minus negative 7. And that's less than 3. And I think this step, even though you can do it in your head, just to acknowledge that stops you messing up on the next line. You've written down what your thinking is and now you can just go ahead. Now we want to force it into this form of x, and instead we've got 3x. So we're going to go ahead and divide everything, and that means all 3 of these terms by 3. So that gives me an x here, minus, now if I divide this by 3, I've got minus 7/3, and here I've got 1. So what that means is that the distance between x and minus 7/3 is less than 1. So minus 7/3, it might be easier if you'd written it as minus 2 1/3. You can use your calculator to change that if you're not good at those. What we're interested in then is we're interested in minus 2 1/3. So go ahead and jot that on your number line. And we're saying the distance between it and x is less than 1. So if I go 1 this way and 1 this way, I'm going to reach minus 1 1/3 and minus 3 1/3. And we're saying that it has to be somewhere in this range, but not including these. These would be open circles. So then our solution would be that x is between minus 1 1/3 and minus 3 1/3. Now doing this the other way, just to compare doing it algebraically, you would say that 3x plus 7 must be between 3 and minus 3. Subtracting 7 from both sides gives me this. And then dividing both sides by 3. And when I say both sides, I mean all 3 sections. That gives me minus 10/3. And oops, we don't have a equal, and this. Now you could then leave your answer exactly like that and it's done. And there's no need to be thinking, well, what's this minus 1 or plus 1? So I tend to think that this not only involves less working, there's less places to make a mistake in it. Over here, it's really easy to fall into the trap of thinking it's something between 3x and 7 and fail to see that it's 3x and negative 7. But if you like this method using the number line, then go for it. It's really good to understand it because it gives you a bit of a more complete picture of what we're really doing when we're finding absolute values.